Hello, my name is Don Horning, and I'm president of Crustbuster and Crustbuster Speed King. We've observed throughout the years that drills are trying to become more like planters, and planters are trying to become more like drills. In this evolution that we see taking place, we thought it would be interesting if we could combine technologies from both the grain drill and from the planter. And the project you're about to see today, that is what we did. And what we did, we set out on this project. We didn't want to employ new technology that had to be developed and tested. We wanted to employ technology that already was being used throughout the industry. I use the term, we didn't want to Daniel Boone anything. We wanted to just take the technology that's available to us and incorporate it and configure it in a fashion that makes sense to us, and hopefully it'll make sense to you as a farmer. We started out with a meter that is as widely spread and as widely used throughout the United States as any meter in existence today. And by adapting this meter over to our needs, now we've, I think, advanced the meter to where we want it to be to be able to plant a wide variety of crops. It can plant anywhere from corn, soybeans, sugar beets, peanuts, cotton, etc. And so this meter then is very universal, and it's very adaptable. And so this is the reason that we selected this particular meter. Precision Planting from Tremont, Illinois, built and made a substantial company out of doing nothing more than taking a meter and tweaking it to gain better singulation and improve the performance of the meter. Now, by taking the meter that's universally used throughout the United States, what we've done now, we've taken the basic raw casting, and where the seed is normally delivered into the seed puddle within the meter, we've added a meter hat or cap. And we've done this by bolting this cover here in the front. And what this now does, it allows us to hook our 3-inch convoluted hose up to the square housing that delivers the seed into the meter. And then secondly, rather than employing chains to drive our seed plate, we have elected to go to the flex drive. This flex drive is a very forgiving drive, in that if you have conditions where you are in a no-till situation and you have a lot of trash and everything, it is not subject to being ridden off like a chain will be. And you take a chain drive, and if you don't keep it oiled properly, it can freeze up on you and you lose your accuracy of the meter. So by using the flexible drive, we've now taken a very universal meter, we've put a cap on it or a hood, not only to deliver our seed into the meter, but also to provide us a cover for keeping inclement weather and weather conditions from affecting the meter any more than necessary. And then to the meter, we have gone with a flex drive, driving off of our 7/8 hex to achieve the kind of driving accuracy that we wanted to be able to get to on this combining of technologies that are already in existence. So we have a proven technology in our meter, we have proven technology in the flex drive, we've added the cover, and then we've added the flex convoluted hose to deliver the seed from the grain drill box into the meter. All right, following the lead of Precision Planning that successfully tweaked the meter and did wonderful things to the existing meter, we kind of thought, let's look at our opener blade and see what we could do here. So we started out with a typical ductile casting. This is an all steel cast that we had poured and made. Then we looked at what kind of a kerf angle. Now the kerf angle is the angle that these blades run at. And so a typical planer will run at about a 14-degree kerf angle. That's the angle between this blade and the outer blade, the two blades. We narrowed this down to a 9.5-degree kerf. We worked very diligently and very hard to narrow this whole thing down to be able to encompass that 9.5-degree kerf. Now the reason that we did that is that 14 degrees, when you're in conventional till and the way we used to plant 10, 15, 20 years ago, the width that you're opening the ground up made very little difference. But as we progressed and as we saw that the more you open that ground up, the more drying you have, the more dry out problems you have, the more closing problems you have with the closing wheels. So we narrowed this up to a 9.5-degree kerf. And so with that narrowness now, we throw much less dirt. We don't open up such a wide slit in the ground. We place our seed in and make it a much easier job for the closing wheels to go ahead and close that kerf over. It requires less horsepower, you move less ground and less drawing conditions. I think that is a good advance forward on our opener. Now we've not only narrowed our kerf angle down to 9.5 degrees, we have increased the size of your opening disc. This is a 16-inch diameter blade. We run two of them side by side. Most and almost typically all planters use only a 15-inch diameter blade. So a 16-inch 4mm versus a 15-inch 3.5 millimeter gives you more wear, better cutting. If you're in a condition where it requires no-till conditions, this blade we think will run better than a typical 15-inch blade. To this blade then, this is an Ingersoll blade made by North American Tillage Tool, a good blade. We have added a stacked bearing arrangement. We've got a cast housing rather than a flange. A flange housing will not take the same amount of distortion and prying angle that this blade is capable of putting on, and so the cast will stand up better. We have a double bearing arrangement. We have stacked two tool forward coil bearings back to back. It gives you much better radial load, much better side load, and will run much longer than a single bearing, regardless of even if the single bearing is a larger bearing. These are 5/8 inch ID bearings, and a 204 coil bearing will give you unparalleled performance. Now to the gauge wheel arms that holds our gauge wheel to the blade, we have selected a rear gauge wheel mounting. And so this mounts behind the blade, and then your gauge wheels bounce to the side. Now we selected this rear mounted gauge wheel because of the fact Case IH has a real good idea on bringing the gauge wheel mounting to the outside of the blade and actually coming around to the outside of the gauge wheel, and therefore you're pulling rather than pushing. The only problem with that is in a narrow row configuration, and more specifically in a twin row, you can't allow that wide gauge wheel arm to interfere with the narrow spacing you're trying to achieve. So therefore we selected a very common gauge wheel arm. We've allowed it to float in the threads, given much superior wear, and then we have an off-center bushing. As you can see, that bushing is off-centered, so that when you turn this, you can bring the gauge wheel to the blade or away from the blade on different angles. And this is a very, very important feature. So you have threads to take care of the weight, and you have the eccentricity of the all-center hole there to allow the gauge wheel to be adjusted to the blade. With our gauge wheel arm then mounted back into the casting, it's very easy now to choose different depth settings. And you can see our butterfly here will allow this gauge wheel to come up to a certain stopping point and then stop. As you can see, this butterfly is a floating design so that one gauge wheel can bring it up while the other one's going down to help level out the flow of that opener. Now the other thing this butterfly is capable of doing, we can lock it down solid so that it can't float. Therefore you can force both gauge wheel arms to a certain depth and hold that depth. And on beds, and especially the loose sandy beds, we feel like it's better to lock this butterfly down, therefore carry a little more weight on your inside gauge wheel than you do on your outside. Now to the opener itself, we have several different varieties of closing wheels that you can mount. Here is a single 1x12 rubber, double 1x12 rubber press wheels. They are staggered, therefore you don't have the ability for two running together to take a corn root and throw it up and lodge it. You have an easily adjustable down pressure where you set the amount of tension you want on your closing wheels. All of this mounted to your cast housing. Okay, the opener is provided with an easily adjustable down pressure spring. In the upper notch is virtually zero down pressure, very minimal. And then every notch you move back adds approximately 50 pounds to the down pressure of the opener. So the spring now is adjustable and settable to the conditions you need to match out with your field. Then as we come around and we look at our box design, here's where we've incorporated some ideas from grain drills. We're using a grain drill box. Therefore, we're getting the capacity of a grain drill rather than that of a planter. Now, the other significance of this, the grain drill box itself is mounted to the frame. And the frame is carried either by your tractor or by your gauge wheels on the frame. So none of the weight of the box and the seed that's in the box is being transferred over to your opener. Therefore, we maintain even and constant down pressure and weight on this opener. And you can see the only weight that we have on it is that of the opener itself. No weight is coming off the box. So on a typical planter, you may have anywhere from 1.5 bushels to a 3 bushel box being carried on the opener itself. 3 bushels times an average rate of 50 to 60 pounds per bushel means you're varying this weight from 150 pounds or 160 pounds down to 0 pounds by virtue of that box as it's full compared to when it's empty. Here we have constant weight on that opener, therefore we are able to more precisely control the depth. So guys, in summary, we've taken a meter that is probably as commonly used throughout the industry of any meter in existence today. The meter has been work done by precision planting, has been tweaked and modified so that in corn, soybeans, you can get that 99.5% accuracy, but yet the meter can still handle crops like peanuts, sugar beets, and other crops that are difficult to plant. So we have the universal meter. We have tweaked our opener that opens the ground. We've closed it from 14-degree kerf down to 9.5 degree. You've seen how we can adjust our gauge wheels, and we have carried the weight of the seed and the box on the frame and not over top of the opener. And this has freed up not only room to get around the planter units, but the most important and most critical issue is that the difference between a full planter box and an empty planter box is very, very minimal because of the fact how we're doing our seed delivery. Thank you. And now let's go out to the field and let's see how these concepts that we went over actually perform in the field. Thank you.
And this is my son Jeremy Breedlove. We operate Breedlove Farms. We grow about 820 acres of peanuts. We planted all the peanuts with new crust buster planter. Had very good success. One of the most benefits we thought of it was we were able to fill up, and to fill up we only had to open 2 lids. We could fill up and run around 11 acres with a filling, and that caused us to only have to fill up 6 times a day or 7 depending on where we ran 60 or 70 acres. And we were very pleased with the way the planter units operated themselves. They had no weight on them from any seed on a hopper, and they floated so well on the ground. And then if we had ground that was not needed a little tension, you could just set the tension on the planter openings, and it would just plant just at the depth you set it real easily.
As my father just before mentioned, the planters delivered exceptional efficiency in my opinion. The greatest ease of it to me would be the fact that we could fill up a large amount of seed at one time and still cover, you know, a larger area with the planters. They gave very little trouble. The accuracy of them seemed to be, you know, to our specification, to our needs. The planters handle well on the back of the tractor. It seemed quite balanced in our opinion. A little taller than what we're used to, but once we got used to it, it's really a very efficient way to load. We're just very pleased with the entire implement, actually. It performed as we expected, actually.
How much did you say you could plant a day?
Well, with this particular unit, with your set of planters, I can cover on a given day almost 70 acres. And we will stop and fill up roughly 6 times to cover that much acreage. And with our previous planters with separate hoppers, our loading time was 2 to 3 times what the loading time is on these planters. So you shorten that time, and that gives you so much additional land coverage each day while you're planting. You know, it helps.
You were saying you could plant almost as much with this rig as you could
I can with 12-row rig.
12-row on singles,
get
right?
Very close to the same daily acreage of planting with this rig as we could 12-row rig.
And that'll cover like 36 feet, right?
It's 36 feet wide.
Yeah, and
That's
you're
right.
covering only like 20 feet here then.
18, actually.
18, yeah.
18. Twice as wide.
Okay.
So.
My name's Paul Maxwell. I was approached several months ago by the Crust Buster peanut planter and decided to buy one and really like it a lot. The machine holds 43 bags of seed, plant roughly 13 to 15 acres depending on how many pounds you put out. And we have planted with this machine up to 6.5 miles an hour, still holding a good plant population, and have had very, very little trouble out of it. And I mean, it's a well-built machine.